Welcome back to another video. Today we will be looking to this problem which is search in a rotated sorted array. So let me just write the heading. So what the problem states? The problem states that we are giving a sorted array but which is rotated at a certain point. So let me just explain you how it is. So this is the array that we are given. Let's assume that this is the array equal to. So this array is sorted, but it is rotatedly sorted. So as you can see, it is sorted from. Let me just write the indexes: 0, 1, 2, 3, 4, 5, and 6. So as you can see, it is sorted from 0 to 3. But after that, it is not sorted. Like it is rotatedly sorted. This 4 to 6 elements should have came before 0, right? Then it would be whole sorted array. But now as you can see, it is we have rotated the array. That means we have shifted the 0, 1, 2 from first position to the last position by rotating it. So this is the rotated sorted array. So we have to search our target. Let's assume our target here, which is given in the question, is 0, right? So it's a 0. So we want to search our target in this rotated sorted array. So what we will be doing here, first approach is of course to have a linear search by traversing all elements, but that won't be optimized solution. We want to optimize the solution by using time complexity of n log n. So when you think of the time complexity of n log n, we in our mind we think about binary search, right? So how do you implement binary search here? As you can see, the binary search is only implemented if the array is sorted. But here it's a not it is sorted, but it's a rotated at some point, right? So what we will do, we will twist our binary search and we will try to customize our binary search at some extent, right? So what we will do, let's check. Let's assume that our low is at point 0, our high is at our high is at last of the index, and our mid is somewhere in 3, right? So what we will do, we will check if our left half, this is our left half, okay, so this is our left half and this is our right half. So we'll check if our left half is sorted or not, and our target element, which is 0, lies in between them or not. And if not, then we'll move to our right half and check if our target element is in between them or not. If it is not, we will move to our left half again. So how we will be doing that? Let's assume this is our target. So we will have some base conditions. So we will check if our first we will check if our low, if our, so we will be using while loop, right, to make a continuous call over it. So what we will do, we will check if array of low is less than or equal to array of mid, right? Which means if it is, it means that our left half is sorted. So if our left half is sorted, we'll move in to our left half and check for the target element. Then we will have a condition if array of low is a smaller than or equal to target, and an array of high is greater than equal to target, right? Which means our target lies between this low and high. What we will do here, we will move our high to mid minus 1, right? So our high will lie somewhere here, right? This is the base condition. If not, what we will do, if our target does not lies between them, which means our target of course lies between the in the right half, so else we will do we'll just move our low to mid plus 1, right? Mid plus 1. So our low will move somewhere here, right? And we will search in the right half. Now if our left half is sorted, left half is sorted, then we use this if condition. But if it is not, then we just move on the right half, right? So we'll move to right half, right? So what we'll do here, we'll just check if our target lies between the right half or not. So what we'll do, we'll check if array of mid is less than equal to target, and then array of, okay, this is my mistake, it will be mid actually, it won't be high. Okay, and if array of mid is less than equal to target and array of high is greater than equal to target, right? Then what we'll do, if our target lies between the mid and high, we'll just move our low equal to mid plus 1, right? Else we will move else, which means our right, it does not lie between the in the right half. So what we'll do, we'll just move our high to mid minus 1, which is this condition, right? So we'll use that condition again. And if we do not found element at last, what we'll do, we will just return minus 1, which is given in the question. If you don't find the element, you just return the minus 1. And if we find the element, what we'll do before this, we will have our own if condition. If like if array of mid is double equal to target, we just return the midpoint, right? So we will just return mid. That's it. Okay. So this is how we will perform this, right? So let's now have a walk through the code and try to search for the target in this. So we will check if the right half is sorted or not. As you can see, left half is sorted or not. So as you can see, the left half is sorted as 4 is less than equal to 7, right? So it is less than equal to 7. Low is less than mid. So when low is less than mid, what we will do, we will check target. If is array of low, which is 0, is smaller than equal to target, is it smaller than equal to target? It is not smaller than equal to target, which means we will move to the else condition. We will move our low equal to mid plus 1, then which means our low will be somewhere around here. So our low will be here now, which is at 4, right? And our high will be here. And after this, we will again calculate the mid, which will come somewhere around here. Okay, so now our array will look something like this. This will be our mid, this will be our low, mid, and this will be our high, right? So now we will again loop over this. We will check if our target is met. It is not. So we will move to this, which is a if array of low is less than equal to mid, it is. So our left half is sorted, which means we will move to the if condition, which is array of low is less than equal to target. Is array of low is less than or equal to target? Yes, it is. And an array of mid is greater than equal to target? Yes, it is. So we'll move our high equal to mid minus 1, which means our high will be at here. Okay. So now our low and high lies at same point. Okay. So low and high is here, mid is here. Okay. So after this, we have moved low high to mid minus 1, which means we will then again move to the top and recalculate our low and high, which should be 0 plus 0 divide by 2. Okay, so it will be at 0th position. Now we will check if we found the mid or not. If the mid element, which is this, again mid will be pointing at this, if mid element is 0 or not, is equal to target or not. If it is equal to target, we just return that midpoint. So we will return this index, which is 4. We got the answer, right? So this is how this code works. So let us walk through the code. Yeah. So this is the code. As you can see, what we have done here, we have got a function for search. So we have implemented the binary search in the form that I just explained. So let low equal to 0, nums high equal to nums dot length minus 1. So here our low is less than equal to high. This loop will run until low is less than equal to high. So let mid equal to math dot floor of low plus high divided by 2. So we want the floor value. We don't want the number in points like in float. So that's why we are doing the floor. So if we got the answer, like if nums of mid is double equals to target, we just return the midpoint, mid index. And if not, we check if the left half is sorted and element lies there. Okay, so we check here, we check if the left half is sorted. If it is sorted, we check for the target element if it lies between the low and mid, and if it does lie, then we will just move high to mid minus 1, and if it does not, then we will move to the right half, right? And if our left half is not sorted, we will just check for the element in the right half. Okay, so here we are checking for the target element in the right half. If we found, then we will just do low equal to mid plus 1, and if not, we will move to the left half, which is low equal to high equal to mid minus 1. So we will just move to the left half and check there. And if we do not found the element, at last we just return minus 1. So let us try to run this. Okay, so it is working. Let me submit. Yeah, so it is working. So you can apply same code syntax in other languages as well, like C++ or Java. It will work. Yeah, thank you.